In this video, we want to show that the derivative of this expression that I have here in the parentheses is equal to the expression on the right. And this is actually the answer from an evaluation of an integral. Of course, there was a plus c here. So this is more or less just a check on the answer. Little exercise in the derivative and a little bit of trigonometry. So I had a plus c here, but the derivative of a constant is 0. So I'll just leave it out for now. So we want to show, we compute the derivative of this, we get this over here. So let's go term by term here. We take the derivative, first of all, the derivative of this right here, that expression together. So let's just do it this way. It's the first function, in this case x, times the derivative of the second one. Derivative of tangent x is secant squared x. And then it's plus the second function, in this case is tangent x, times the derivative of the first. The derivative of x is 1, so this is just multiplied by 1, which is not going to change it. And then it's plus. And then we want to take the derivative of net log of absolute cosine of x. So the formula for that is simply you put the expression in the absolute values in the denominator, and then we take the derivative of what we have in the absolute values. But the derivative of cosine is minus sine of x. And then here we have minus then, and the derivative of x squared over 2, basic derivative here, bring the 2 times the 1 here, over 2, so that'll just give us minus x. So we got that so far. So let me just rewrite this. So all we're doing is taking the derivative of the expression on the left. We want to show it gives us the expression on the right. Again, it's just an exercise in computing the derivative and a little bit of trigonometry. This is plus tangent of x. And then here we have sine x over cosine x. That's just tangent, so we'll just make this minus tangent of x minus x. But tangent of x and minus tangent of x cancel. So in my next step then I'll have x. Now we're actually finished with the derivative, but we want to show that it's the expression on the right. So we have to continue here. So it's kind of like verifying a trig identity. So we get this. So again, we're trying to get x tangent squared of x. So here you can see we can factor out an x. I take out an x. That leaves us with secant squared x minus 1. And you should recognize that now at that point. We know that 1 from basic trig identities, we know that 1 plus tangent squared of x gives us secant squared of x. So if we take this one over to this side, get minus 1. So we get secant squared x minus 1 is tangent squared. So from that then we can conclude that this will give us x tangent squared x, and that's what we wanted to get. Thanks for watching. We'll see you next time.